students, welcome to Vidya Myriad. This video is made for class 10 on chapter number 1 real numbers, and today we are going to do exercise 1.4. Let's begin with question number 1. Without actually performing the long division, state whether the rational numbers have a terminating decimal or non-terminating repeating decimal expansion. Now the rule to understand whether the rational number has terminating or non-terminating is very simple. You need to just look into the denominator. If your denominator has the factors 2 or 5 or 2 and 5, no other number is there. That means either 2 should be there or 5 should be there, or both can be possible. Only then it has terminating decimal expansions. Other than that, it will have non-terminating decimal expansions. So for every question, for every fraction, we will check the denominator whether it has the factors of 2 or 5 or not. So let's begin with it. First part, 31 upon 3125. Now ignore the numerator, we don't want 31, just focus on 3125 and find out its factors. So factors of 3125 is in a form of 5 raised to power 5, and we know that if the factors are in 2 or 5 form, only then it has a terminating decimal expansion. So we can say in this that 31 upon 3125 has a terminating decimal expansion. Next, 17 upon 8. Now 8 has the factors 2 into 2 into 2. So that means it is in a form of 2. So it is also a terminating decimal expansion. 64 upon 455. So factors of 455 is 5 into 7 into 13. It is not in the form of 2 and 5. So we will say that it is a non-terminating decimal expansion. 15 upon 1600. So it has an expansion 2 raised to power 6 and 5 raised to power 2. So they are in a form of 2 raised to power m and 5 raised to power n, and thus we can say that it is a terminating decimal expansion. Next, 29 upon 343. So 343 is 7 cube, and 7 cube is not in the form of 2 and 5. So that means it is a non-terminating decimal expansion. 23 upon 2 raised to power 3 and 5 raised to power 2. It is already in a form of 2 and 5 factors. So we can directly write down it has a terminating decimal expansion. Next part, 129 upon 2 raised to power 2, 5 raised to power 7 and 7 raised to power 5. Now here in the denominator we have 2, we have 5, but there is one more 7 in it which is not acceptable. So we will say that it is a non-terminating decimal expansion. So that means for terminating, only 2 and 5 should be there. 6 upon 15, which means 2 upon 5, it can be reduced. It is in a form of terminating decimal expansion clearly. 35 upon 50, that is 7 upon 10, and 10 has a factors 2 and 5. So it is also a terminating decimal expansion. 77 upon 210, which means 11 upon 30, it can be reduced, and 30 has the factors 2 into 3 into 5, which is not in a form of 2 and 5 because there is one more 3 into it. So we will say that it is a non-terminating decimal expansion. Question number 2. Write down the decimal expansion of those rational numbers in question number 1 above which have terminating decimal expansions. So all those parts which has terminating decimal expansions, we are going to do the division for that and see that the remainder comes to be 0. It should finish. Terminating means it should finish that divisions. So we will divide 13 with 3125. You will see that your quotient or your answer is coming as 0.00416 and your remainder is coming as 0, and we proved that it is a terminating decimal. Second part, 17 divided by 8. So when we do that, we get your answer as 2.125 and remainder as 0. So our division stops at 5. So we will say that it is a terminating decimal expansion. 64 upon 455. It is a non-terminating decimal expansion as it is not in a form of 2 raised to power m into 5 raised to power n. So we are not going to divide. Next, 15 upon 1600. So let's divide and see. You will get 0.009375 and you stop at 5. Your remainder comes out to be 0 and thus it becomes a terminating decimal. 29 upon 343. What is 343? 343 is 7 cubes. It is not in a form of 2 and 5. So it is a non-terminating decimal expansion and we are not going to divide this. Next, 23 upon 2 raised to power cube and 5 square, which means it is 23 upon 200. So when we divide and see 23 upon 200, we get your quotient as 0.115 and your remainder comes out to be 0, thus proved it is terminating. 129 upon 2 raised to power 2, 5 raised to power 7 and 7 raised to power 5. We know it is a non-terminating as it is including 7 in the denominator, which should not be there. Next, 6 upon 15 is equal to 2 upon 5. We can reduce it. So we can divide it and see that our answer is 0.4, remainder is 0. Next, 35 upon 50. 35 upon 50 can be reduced in a lowest term and it comes out to be 7 upon 10, which is 0.7 and remainder is 0. And lastly, 77 upon 210 is a non-terminating decimal expansion and we will not divide this. Question number 3. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form of p upon q, what can you say about the factors? So number 1, they are given as 43.123456789. So it stopped at 9. It means it is a terminating decimal. And when you have a terminating decimal, it means it can be presented in a form of p upon q, which should have the factors in the denominators as 2 and 5 only. Next, 0.120120012001240. What does it mean? This is non-terminating, non-repeating. It's not repeating, it's going on. The numbers are changing. That means it is an irrational number. It is not a rational number. Next, 43.123456789 bar. There is a bar on it, which means the numbers will be repeating. It is non-terminating, it is not stopping, but it is repeating decimal because after 9 it will again start with 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9 again it will start, it will go on, it will not finish, but it is repeating in nature. So we will say that it is in a form of a rational number which can be presented in a form of p upon q, and the denominator will have the factors 2 and 5. That's all for this exercise, children. Please do lots of practice. You should be careful while doing the division parts because the division will be quite long. Don't get scared with this. Do lots and lots of practice. If you have any doubt, you can mention in the comment section or you can also email me. Thank you so much, children, for watching the video till the end. Very soon I am going to come with the next video. Till then, see you, children. Goodbye. Take care.